Good day, math learners! Welcome to Session 5, Definition of Parabola. In this session, we will be talking about parabola, and we begin our discussion on parabola on the definition of the parabola. Our learning competency for this session is define a parabola. And basically, our specific objective is to define parabola. Alright, so what you see on the right is a photo of a dish satellite of CVI or cable network in the city. By the way, thank you so much PCVI for allowing me to take a photo of your dish satellite. This is a paraboloid antenna. Okay, and where do you think can you find this? You can find this along Pedro's Cafe in Bye City, and this is beside the PCVI office, the Cable Channel 8 office. Okay, so now let us try to formally define what a parabola is. Parabola is the locus of points on a plane whose distances from a fixed point, called the focus, and a fixed line not passing through the focus, called the directrix, are equal or the same. Were you able to get that? Alright, to better understand that, let me illustrate that to you. Okay, let's try to draw it. Let's try to plot it. How does it look like? What is a parabola? Why is it described that way? Okay? Alright, so let me draw that for you. Let's try to pick the white one first. Okay, so let me try it here. Okay, let this be our x line. Our y line, and let this be our x. Oh, it's really not that straight. Let me do it again. Takes me a lot of concentration. I'm really new to this. Again, it's not really straight. One more time. Let's do it one more time. Okay, this is our y. And this is our x. Alright, that's better now. Okay, so from the definition, it's the locus of points on a plane whose distances from a fixed point, called the focus, okay, and a fixed line not passing through the focus, called the directrix, are equal. So before we can really look and see how a parabola looks like, but I know you are already familiar with how it looks like, let's try to identify first our fixed point and our fixed line, right? So let me use another ink. Let this be our fixed point, this point here. Okay, so let's try to call this F for focus. Okay, and let's say the distance from the focus, the origin, is equal to C. Okay, therefore we can say that the coordinates of the focus, the F, is 0, C. Now let us identify our fixed line, the directrix. It says that the directrix does not pass through the focus. So therefore we cannot draw the directrix along the focus. Maybe we can place it somewhere here. Let's say this is our directrix. Directrix is line L, right? So let this be our line L. And let us say the coordinates, the distance from the line, on this point of the line, the origin, the distance is also C. Okay, so therefore line L passes through negative C with coordinates 0, negative C. Therefore, we can say that the equation of our line is y equal to negative c, right? All points here, whatever your x is, your y is equal to negative c. Now, let's try plotting. Let's start plotting for parabola. So obviously, because the distance from the origin to F is c, and the distance from the origin to line L is also c, there is an equal distance between this origin point on the origin, and the focus and the directrix. Therefore, we can say that the origin, this point here, lies on the parabola, because the condition is that it's the set of points, the locus of points on a plane whose distances from the fixed point and from the fixed line are equal or the same. Therefore, this point is obviously on the parabola. Now let's try to find another point who has the same characteristic. Let's try to have this point here. Okay? If the distance of this point to our line L, to our directrix, this distance is equal to the distance of this point to the focus, okay, this one, that's equal, and this point is also on the parabola, right? Let's try to find another point. Let's say this point here. Again, if the distance from this point to our line L is equal to the distance from this point to the focus, okay, if this distance and this are equal, then this point is also on the parabola. One last, let's say this point here, right? So if the distance of this point to our line L, we're going to extend the line going that way, just to make you contented with it. Alright, so if distance from this point to line L is equal to the distance from this point to the focus, okay, then this point must also be on the parabola. If we connect all these points, look at how it looks like. We connect them with a smooth curve. It obviously will go that way, okay? And if we're also going to find points that will also lie on the parabola on the other side of the Cartesian coordinate system, on the second quadrant, then this point will be one of it. If the distance of this point to the directrix is equal to its distance to the focus. Same maybe with this point here and this point, such that when we connect them, when we connect them with a smooth curve, alright, I am still adjusting with this application, and that's how our parabola looks like. So this is how the graph of a parabola looks like. Okay? Now let's try to observe our graph. We're going to look at it. Let us try to look at the focus. Okay? Let's give emphasis to the focus. This one. Let's try to write our notes on the side. Important notes that we can get from this part. Focusing on the focus. Let's start with the focus. We can say that the graph is opening towards the focus. Correct? Opening is going towards the focus. So, from that we can say that the parabola will try to open where the focus is. There's a dramatic way to say that. I have read some books and it says that the focus, the parabola, is trying to devour the focus. It's trying to eat up the focus. Okay? So if it tries to devour the focus, then the focus will always be at the concave part of the parabola. It's like on the inside part of it. Okay? That's for the focus. Now let's move to the axis of symmetry. Okay? So the axis of symmetry, the line of symmetry of our graph is this one. Okay? This line will try to divide the graph into two equal parts, right? The axis of symmetry will always pass through the focus. It passes through the focus, and it touches how many points on the graph? It touches 1 point. 1 point on the graph. 1 point on the graph is touched by the axis of symmetry, and that particular point is what we call this particular point the point where the axis of symmetry passes through, the point on the parabola. We call it the vertex. The vertex of the parabola. So the vertex is the turning point of the graph. As you can see from the left to the right, the value is from the center, from the vertex, going to the going to the left of the graph, left side of the parabola, the value is increasing. And also going to the right, the value is also increasing. It means that as the graph moves closer from the left to the vertex, the value is decreasing. But when it passes through the vertex, the value is already increasing. Alright, so that's why the vertex is the turning point of our graph. Now let's move to another thing that we need to note. Number 3. Number 3 is what we call lattice rectum. What is a lattice rectum? A lattice rectum is actually the segment. It's a segment that joins 2 points on the parabola and which passes through the focus. So let's try to draw our lattice rectum. So if it will pass through the focus and touches 2 points on the parabola, so maybe it could be this point here. So if these 2 points are joined and it passes through the center, through the focus of the parabola, then we have now our lattice rectum. Again, the lattice rectum is the segment whose the end points of these segments are points on the parabola, and that particular segment passes through the focus. And while it passed through the focus, as you can see, this lattice rectum and the directrix are parallel. Okay, so the lattice rectum and the directrix are parallel. The lattice rectum is a segment while the directrix is a fixed line. That's it, math learners! I hope you have learned something today as we discussed about the definition of a parabola. See you on the next session. Bye!